giving the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. So the question is saying this linked list is given to us. We should first check if there is a cycle, and if there is a cycle, what is the entrance point? As you see in this example, there is a cycle and the entrance point is node 2, and this is what we are going to return as a result. In this example, there is a cycle and the entrance point is node 1. And in the third example, there is no cycle and we are going to return -1 or null. So the question is saying the number of nodes can be 0 to 10 power 4. And the question is asking us to see if we can do it in constant space complexity. So let's see how we can solve this problem. If there was no constraint like using it in constant space complexity, we could use a hash map. We could iterate over the nodes and add them to the hash map, and if we see a node twice, then we knew that there is a cycle and we could return the entrance point. But because we want to use it in constant space complexity, we are going to use Floyd algorithm. What is Floyd algorithm? Floyd algorithm is going to use 2 pointers, a slow pointer and a fast pointer. The slow pointer at each iteration goes 1 step forward, and the fast pointer at each iteration goes 2 steps forward. Let's have an example here. So this is the example that we have, and as you see, we have a cycle and the entrance point is 6. So let's see what we can do with this Floyd algorithm. What we can do, we can find the intersection point by using Floyd algorithm. And you might say, why do we need to find the intersection point between the fast and slow pointers? When we find the intersection point, the distance from the intersection point to the entrance point is equal to the distance from the head of the linked list to that entrance point. And this way we can find the entrance point to the cycle. So let's go through the code so you can better understand this. So what we are going to do, first we are going to find the intersection point, and then what we are going to do, we are going to find the entrance point. For finding the intersection point, as I said, we are going to use Floyd algorithm. We are going to use a fast pointer and a slow pointer. At the beginning, they both are pointing at the head of the linked list. And then we are going to use a while loop, and as long as there is the fast pointer is pointing at a node with a value, and fast.next is has a value in it too, we are going to move the fast pointer 2 steps forward with 2 nexts, and we are going to move the slow pointer 1 step forward with 1 next. And at each iteration, we are going to see if the fast pointer is equal to a slow pointer. If they are equal, it means we have found the intersection point, and we can break this while loop, and we know the fast pointer and a slow pointer, they are both pointing at the same node. And then what we can do, we can check if there is no cycle. And if there is no cycle, it means the fast pointer has iterated all over the linked list and is pointing at none. And if it is pointing at none, it means there is no cycle, and we are going to just return null as a result because there is no cycle, right? So we are going to say if not fast or not fast.next, what we are going to do, we are going to just return, and that's it. We are done with the coding. But if there is a cycle, so it means the fast pointer and slow pointer are pointing at the same node. Let's go through an example and see how it works. So let's say fast pointer and slow pointer both at the beginning are pointing at the head, but at each step a slow pointer is going 1 step forward and the fast pointer goes 2 steps forward, and this goes 1 step forward, and this goes 2 steps forward, and this goes 1, and this goes 2, and this goes 1 step forward, and this goes 2 steps forward, and this goes 1 step forward and 2 steps, and this goes 1 step forward. And at this point we have a cycle. So for going 2 step forward, it's gonna be from 11 to 6 and 6 to 7. So fast pointer is going to point at 7 and a slow pointer is pointing at 7. So the intersection point here, intersection point is going to be node 7 here, right? After finding that, what we are going to do, as I said, the distance from intersection point to from the intersection point to the entrance point is equal to distance from the head of the linked list to the entrance point, right? But for finding that, what we are going to do, we are going to move the slow pointer to the head of the linked list, right? We are going to move it here. And when they meet each other, it means that's the entrance point. For doing that, we are going to move the slow pointer to the head of the linked list, and we are going to have a while loop, and we are going to say while fast and a slow pointer are not equal. As long as they are not equal, we are going to move them one step forward, right? Fast, that's next, and a slow is going to move one step forward, that's next. And when they meet each other, that's the point that we know is the entrance point. Let's see how it works. So we are at point 7, we are going to move fast one step forward, it's going to be 8. We are going to move this one step forward, it's going to be 2. One step forward is going to be 9. One step forward is going to be 3. One step forward is going to be 10. One step forward is going to be 4. One step forward is going to be 11. One step forward is going to be 5. So there is a cycle here. One step forward is going to be 6, and one step forward is going to be 6. So this is the entrance point. What we are going to do, entrance is going to be node 6, and we are going to return that, return fast, and that's about it. And as you see here, we could find the entrance point. Let's run this code. Let me remove this. Let's run this code and see how it works. So while, oh, sorry, I made a mistake here. So it seems, oh, return typo. You should be very careful about typos. And as you see here, it's accepted in 38 milliseconds. So the time complexity for this is going to be linear because we are going to iterate over the linked list once. And for space complexity is constant because we are not using any extra space. Thank you.